Hey everyone, today I'll be doing Leetcode Weekly Contest 279. It's just about to start, and then after I finish the screen class, I'll go through the solutions. Anyway, wish me luck. Hopefully you don't get rate limited, and let's go. One increasing, none decreasing. Okay. We'll just do. Alright. 2, 3, 4, 1. Um. Hmm. Alright, that should be good enough. Is he? The total number of bits. Yeah. Okay. I could have just done like this though, right? Yeah, like return software account. Like I can do that, right? Let's get rid of that. Line 33. All right. That should be self-dot. Yes. Come on. So I have a lot of variable name duplication, which I did not realize. Okay, hopefully that's good enough. Oh no, false, no, true. No, 2, 0, 1, 0, 1, 0. Oh. Oh, okay, I'm stupid. Okay, that's still wrong. Okay, that's still wrong as well. And they're both wrong. Self.f. Right. Seems better. Alright, I got AC. And that's disappointing. So what do I want to do? I want to maximize. Prefix max plus x plus r minus l. Okay. Alright, let's just try printing out that. Okay. Zero, 3, and alright, that didn't work. Well, maybe you shouldn't work. I could just be off by 1, but I don't want to risk it. Like it could just be that. That does give me the correct answer. Okay, that is indeed wrong. It might be that. Oh, I'm stupid. I forgot that needs to be that. That's still an obvious wrong answer though. What if I change that order around? Okay, that didn't work. Oh, I just don't want to. I'm not sure why I'm negating that. I don't want to negate that. Two. It's not going well. What am I doing? That should be plus. Five two zero two two. Alright, we're gonna submit that. Okay, that got accepted. So that was pretty slow. Let's just take a look at where I am in the leaderboard. So not great. Some people finished in 9 minutes. Okay, anyway, I think I'll just go through the solutions very quickly. Okay, so this question is pretty basic. All I'm doing is, first I'm separating the numbers into 2 arrays, one for the odd indices, one for the even indices. And then all I want to do is I can sort the odd and the even ones. I can sort the odd and the even arrays independently, and then I'm just going to combine them to their answer. And so I need to sort the odd numbers in decreasing order and the even array in increasing order. I've actually done the opposite here, and that's because if I sort with the opposite and then I append .pop returns the last element in this list, it just makes it's kind of convenient for me. So for example, I want the odd indices to be in descending order, but what I do is I just sort it in ascending order, and when I want to add in an odd element, I'll just take the last element from that array. I did this just because .pop is pretty easy and it's an L1 time. Anyway, okay, this question, there's a few different cases, mainly whether we have to deal with the negative sign or not. So let's assume that the number is positive for now. If the number is positive, then to minimize it, we just want to sort the digits in ascending order. The only problem with this is if we sort it in ascending order, there may be trailing zeros. So for example, here the number is 310. So if our number, for example, was that, then sure, I can just sort that in ascending order. But now let's say that there was also a 0. I wouldn't be able to make this string. So what I have to do instead is, since it has to start with a digit, I will choose the smallest digit. In this case, that's the 1. I will put the 1 in the front, and then I'll sort all the other characters I haven't taken yet, and I'll put that in ascending order. And that's essentially what I'm doing here. If there isn't a 0, then I can just sort the digits. Otherwise, I'm going to find I. In my code, I is the smallest non-zero digit that is in the smallest non-zero digit that's part of numbers, that part of num. And then I'm going to remove this from the characters. I'm going to sort the other digits, and then I'm going to put that minimal number in the front. And when num is negative, since there's a negative sign, what we actually need to do is, if we ignore the negative sign, we simply need to maximize the value of the remaining part. And so you can just sort it in descending order. And since we're sorting in descending order, that will guarantee that we don't have trailing zeros. Because a negative number must have at least one non-zero digit. And I wasn't sure, if num is 0, I just handle that as an edge case. Anyway, that's how I did this one. Okay, so this question is, all of the operations are fairly simple apart from the flip one. Obviously, we can't go and flip every single character by itself. So instead, what I do is, I have variables for, I'll just explain what my variables are. So self.s equal, that is like our bit set. It's like literally what does our bit set look like. And then in the toString part, I'm just outputting this array basically. A self.o is just the number of zeros in self.s. And finally, self.f is the number of times the flip operation was performed. So basically, self.o and self.s is that will store the value that would store what my bit set would look like if I didn't perform any flip operations. So if I didn't perform any flip operations, then self.s is what the bit set would look like, and self.o would be so it would be the number of ones. And basically, when I want to print my thing, all I do is I take my current self.s bit set, And if I have to flip it, then I'm going to flip every element in it, and then I'm going to output it. And then, okay, so the other thing that's to note is if you flip something 3 times, it's essentially the same as flipping it 7 times, i.e. only the parity of the number of times you flip matters. So self.f in my implementation will only ever be 0 or 1. 0 if you don't need to flip it, and 1 if you do need to flip it. And that's why in my 2-string code, so this is the XOR. Basically, the XOR, what it's essentially doing is if self.f is 1, meaning that it needs to be flipped, then each 1 will turn into a 0, and each 0 will turn into a 1, i.e. each element will be flipped. And if self.f is 0, representing that I don't need to flip anything, then nothing will happen, and I'm just outputting self.s. So all my operations are actually pretty standard, but the only thing to be wary of, this is where my bug came off. Let's say I need to fix an element. If I haven't done a flip, then first I check if it hasn't been flipped already. If it hasn't been flipped, then I'm going to set that bit, and I'm going to increase the number of ones by 0. The part which I forgot to do is, if I have flipped it, instead of looking to check if any element is 0, if that element is 0, now I actually need to check if that element is 1 because it's been flipped. If that element is 1 now, then I'm going to set that bit to 0 in self.s and subtract 1, 1. And keep in mind that these values are what it would be if I didn't perform any flip operations, so they will be corrected later. And then unfix is exactly the same, just the other way around. All you have to do is just change this number. When I flip every element, I'm just if self.f was 0, I'm going to turn self.f into 1, and if self.f was 1, I'm going to turn it into 0. And basically that's just this will store the parity of the number of flips. For count, if it has been flipped, then it's actually the total length of the string minus the number of ones, because this will be the number of zeros, and since the number of zeros after flip turn into ones, that's what I need to output. If I haven't flipped it, it's just self.o. This part is unnecessary. To check if it's all flipped, I just check if the number of bits which is set is equal to the length of the array. To check if there's at least 1 bit set, I just check if the number of bits is more than 0. And that's all I have for that question. Okay, so it's not looking great. 38. Okay. So I actually changed my implementation quite a bit, which actually wasn't particularly good. This statement is pretty bad, but anyway, here's my main idea. So I have 2 arrays P and S, and when I do this, usually it means P represents a prefix and S represents a suffix. And in this case, I'm saying Px is the number of moves to clear off the first X elements using only left operations. I.e., for example, if I have this string, then P of 0 is 0, P of 1 is 1, P of 2, P2 is 2, P3 is 5, and P4 is 7. And that, for example, means for P3, that means that I would need to remove a car from the left end 5 times in order to eliminate the first 3 cars. And then S is the same, but it's for the right-hand side. Basically, I think if I remember correctly, I've defined it slightly differently. I think S1 is the number of moves to take all of the cars up until the first car from the left. I.e., in this case, S1 would be 7, S2 would be 6, S3 would be 3, S4 would be 1, and S5 would be 0, for example. And that, for example, for S3, that means that from the third car onwards, I would need 3 moves from the right to delete it. And essentially what I'm doing is, we observed that in the optimal answer, I would be removing some prefix of this array using left operations. I'd be removing some suffix of this string using right operations, And then for each remaining one, I would remove it using the third operation. So basically, let's say L and R. Let's say L means I'm taking all. Let's say L means I'm removing the first L cars. First L cars using left operations. Move from the left, and R represents that I'm removing cars from the right from the auth car onwards. Okay, in this case, it would take PL time to remove the L cars from the left. It would take SR time, SR time to remove the cars from the right from the auth car onwards. And then R take L take 1 is the remaining number of cars in this sequence. And then I need to times this by 2, which I forgot, because removing from anywhere takes 2 units of time. So I'm just trying to minimize this sum, where L has to be less than R, because obviously I can't have a car that's being removed from both the left and the right. And basically, I can rearrange this statement to be PL minus 2L plus SR plus 2 times R subtract 2. And basically, ants is going to store the maximum value of this part of the sequence, and then in the end, I'm just going to subtract 2 to account for this part. Okay, so how do I update ants efficiently? Well, let's say we fix R. So if we fix R, then this expression is fixed. And then all I need to do is, for all elements that I've processed so far, because I'll be looping, for each element that I've processed so far, I will keep track of the minimal value of this expression. In my code, I'm looping through R from 1 up to the length of S. And then and left is going to store the minimum value of this which I've processed so far. So when we get to our current R, I'm going to take this expression, which is here, and I'm going to add that to the minimal value of this which I've seen so far. And then I'm going to update the minimal value of this which I've seen so far, which is the value left, with this expression. And basically, that guarantees that every time I've processed the variable R, I would have processed left for all elements before it, which is essentially what I do. For each R, I want to process all L's before it. And that's basically how that works. Anyway, that's pretty much all I have for you today. It seems that my final rank is 38, and I'll see you guys next time.